I keep dreaming up this coffee table, each time adding more features, more ideas, until it's almost beyond what I could actually build. But I guess the only way to find out if it's possible is to attempt to make it real. And not some boring regular coffee table, more like an espresso table. I'm envisioning a coffee mug warmer, chiller, wireless charger, a smart home controller panel, side shelving, secret door, fridge. Yeah, we're gonna need a better plan. In reality, for the last 6 months, I've been planning this backwards and forwards, designing, sourcing, and building like crazy. And after all of these months, it's finally done. But before we get to the reveal, there are still a few key features I need to add to set this thing over the top. This video is sponsored by JLC 3DP. For those of you who haven't seen parts 1 and 2, this video will serve as a condensed version with commentary, a start to finish. So to start out, this is a stationary base, and I'll mount this big beefy Lazy Susan type deal on top. The coffee table will then spin on this platform. Many coats of primer and paint, and we'll let that dry and get back to that. Next up is incoming power. I'm using a pretty substantial Dell power brick along with a nice fabric cord. I'll have to do some soldering to modify this, and then will be integrated into the base along with a slip ring. Moving on up is the structural part of the project, as well as part of the shelving that will be integrated into this coffee table. I'm going to cut this up, do a dry fit, and apply some walnut veneer on top. I'm using 3/4 inch oak ply. Adding a USB-C charging port is a must, and then we move on to the shelving. I picked up a cheap offcut of Corian, a common countertop material. This stuff is pretty easy to sand, as you can see there's some scratches, so I'm gonna hit it with 120, 220, and go all the way up to, I believe I did 1000 grit. Here's the dry fit. I'm in the process of explaining how this base will rotate. I mentioned the slip ring earlier. It's basically an electrical device that lets the coffee table spin freely without the wires getting tangled, so I can rotate this continuously and still have power. It wouldn't be a crazy coffee table without a custom fridge. I'm using a cheap Peltier device to cool this fridge down, but first a quick test to make sure it actually works. These things catch a lot of flack since they're not the most efficient way to cool a space, but for my setup, they're perfect. It's dead silent, has a tiny footprint, and I'm not aiming for a fridge or freezer temp anyway, more like a wine or water cooler in that 50 to 60 degree sweet spot. Then on to insulation, a cooling radiator, and some LEDs to light this thing up. And I forgot to mention, this cooling device spits out a lot of heat at the other end, which needs to be dissipated. I'll talk more about this later, but I'll be using water cooling, like in the PC world, to keep it at a stable temp. Consider subscribing if you like this kind of content. It helps make these large build videos feasible. I'm just gluing up some of that nice walnut I have for the actual sheath around the coffee table, as well as some of the shelving as well. Finally, on to actually assembling the bottom of this table. This cutout section will hold the fridge once it's finished. I'm using a 3D printed radius guide to help when I eventually route this out. I'm adding some cool ambient lighting on the shelf itself, and I might as well add some of the electrical components in here before I close this thing up. I need to make a housing for the display I purchased using my RevoPoint 3D scanner. It works great for this. I can scan it in, pop it into CAD, and begin building around the mesh it creates, saving me time and, most importantly, clicks for my wrist. I also scanned in the motor I will be using for the finishing touch for this coffee table, but you'll have to wait until then to see what it is. I'll have a link down in the description if you're interested in this type of scanning technology. For the aforementioned water cooling, I'll be using a PC pump and a fan and radiator setup. Again, printing jigs and a mount as my application is not very standard. There's also a bracket for the battery. Yes, battery. This coffee table will have a built-in power backup. I originally planned on using a magnetic disconnect for the main power so there wouldn't be a visible cord, but that didn't work out the way I wanted to. There's also more circuitry going in, including a custom charging circuit, a power distribution circuit setup, and fuse protection across the sections of this coffee table. Then simply a quick test with a antifreeze/water combo to ensure no leaks. On to making this thing look pretty now. I'll sheath this coffee table with walnut slats. Well, not true walnut slats, veneered plywood essentially. Finally, I'm routing out the fridge slot, adding veneer to the front of the slats, and giving everything a quick sanding followed by a hardwood finish. Things are really coming together now. We're mating the stationary base to the bottom walnut slatted section. I added some furniture pads underneath and secured the two pieces together with screws through a convenient hole from the underside. The fridge is then going into the bottom section along with some thermal paste with the water cooling system. Now, as you may have noticed, I started the fridge but didn't add a door. We're going to take care of that now. I'm using a 1/4-inch piece of acrylic and a custom jig. Then I will melt it in the oven to form it to shape. After that, I'll double wall the fridge to create an air gap, which will make it much more thermally efficient. I'll glue everything together using some super glue and RTV silicone to seal it all up. As that's all drying up, we'll focus on the dashboard now. My longtime sponsor JLC 3DP is handling the display housing using one of their many advanced 3D printing options. I simply export the model from my CAD software as an STP file, then choose the resin type, color, and any other surface treatments. In my case, a smooth sanded finish. Ordering is quick and straightforward, and what I really like is that the CNC and mechatronic parts can be added in the same checkout. My parts arrived fast and turned out great, far better than if I printed them myself on an FDM machine. I also upgraded my heated and cooled plate bracket to an aluminum version for improved heat dissipation. If you're looking to bring your projects to life, definitely check out JLC 3DP. Links down in the description for coupons and more information. Now moving on up, literally on the top section, I'm cutting out a few pieces, including acrylic and MDF, getting them painted and assembling everything into a nice sturdy platform for what's coming next. An ambient glowing ring around the perimeter and a fabric edge wrapped around the table. For both the glowing ring and underlighting, I'm using a WLED controller that Gladopto sent over. It has 4 zones, which makes it perfect. I'll have links in the description if you want to check it out. And I'm using just standard 12-volt addressable lighting, addressable every 3 LEDs, just so I can have some variety in the colors I want. To give this coffee table a bit of contrast, I'm adding a plywood layer that'll be veneered to create a walnut ring just below the Corian top. And I finish it with some hard wax as well and attach that. I attach the top section to the nearly finished base using some long M6 bolts that thread into the inserts I added earlier. Next, I mount the fridge door and did some quick testing. Everything worked well, though I plan to improve it with an internal fan to circulate cold air more evenly around the chamber. Then I turned my attention to cutting the CNC countertop I got locally. I routed the profile and details like the integrated wireless charging zones and lightning bolt indicators. I did all of this on my modified Shapeoko CNC. After cutting, I installed the hardware and filled the indicator holes with epoxy. You might notice some foil tape in that section. I ended up removing it since it interfered with the wireless charging. I replaced that with black paint instead off camera, which helped block light bleed as well as make the charging indicators work. Since the Corian is actually fairly translucent, that's why I had to do all this. I sanded down the Corian down with multiple grits and finished it off with a polishing compound afterwards. I then proceeded to put LED lights in the indicator charging locations and worked on the heated and cooled plate. It's the same principle as the fridge. This little unit can heat and cool depending upon which way current is flowing. This top section is packed with wires, tubes, and all sorts of stuff. What you're seeing here is a small reservoir that collects condensation from the heated and cooled plate, draining it down into the bottom of the fridge. Finally, before getting into the last upgrades, we have to build the brain of this coffee table, so to speak. It's powered by a Raspberry Pi. I didn't show much of the coding because there's a lot going on. I'm running Home Assistant on this display. I spent about 2 weeks writing and tweaking scripts to play nicely with the hardware I have, and customizing the dashboard. It just was a lot of work. I'm not quite there yet, but I'm getting close. The upgrade I've been hinting at is a task light that rises from the surface of the coffee table when needed. It's hooked up to the Raspberry Pi, and I borrowed a few parts from my 3D printer to get started, figuring out the lift mechanism. I first tried using small O-ring gaskets, but they were a bit too slippery, so instead I made a custom mold using platinum silicone to create a flexible coupler that connects to the stepper motor and drives the light up and down. The silicone honestly came out pretty great, and it was very grippy, and the only thing was it was really difficult to get it out of the mold. So here it is. I then printed a bracket to secure the stepper motor and the linear guide rail that will move the rod up and down. This little limit switch will serve as the upper limit of the stepper motor, and then in the code I will have it homed to that location, and it will reverse when I turn off the light essentially. I did notice the rod was a little tight, so I actually ended up sanding this down and polishing it with various grits. Basically, the light and motor are controlled by the Raspberry Pi, all powered through this breakout board I'm putting together. I've tested it, but I'll do a quick sanity check to make sure it actually moves up and down before I shrink everything down into a smaller breakout board that'll fit neatly in the section I planned for. From the previous build, I already had this Corian piece cut out for the task light. I sanded it down, and then I'll move on to painting it. I'm painting because, again, it's translucent and the light will actually shine through and cause it to look a little weird. And in the end of the video, you'll see I actually changed this again. I put a walnut veneer on top of it because of that bleed through. I will use some 2-part epoxy and fix the rod in place and put the LEDs on there. Here you can see the breakout board. It's a lot smaller, and I wire that up and fix everything together. After everything was successfully installed, I turned to the 3D printer to print a diffuser, which I lost the video footage of, but that goes on the light. And now to move on to the dashboard, the touchscreen dashboard, I'm using the SLA print that my sponsor printed out that I fully designed custom for this application. And that's it. Before we move on to the reveal, I just wanted to thank anyone who's still here, and definitely consider subscribing if you enjoy these kind of projects. Either way, enjoy the ending.